Okay, welcome to another Orbiter 2010 video, and this is actually going to be a series of videos where I'm going to try to show how to go from Earth to Mars using TransX. I've already done an Earth to Mars video using TransX, but I wasn't all that happy with the way it worked out, and I felt like it could use a lot more detail and just a lot more explanation overall. So I'm going to do that video again, but this time I'm going to break it up into as many parts as I feel is necessary in order to get an explanation that is hopefully thorough enough to make me feel content that I at least did my very best. So let's get started. In this first part, I'm actually going to talk just about the date. So we're not actually going to get going to Mars in this particular video. So I'll just kind of warn you right now. In this video, I'm just strictly going to talk about how important the date is for getting out to Mars. So you can see here, hopefully you can see, it's kind of hard to see these colors sometimes, but up here you can see it says the date is Thursday, August 9th, 2012. It's kind of an arbitrary date, nothing special about it. But, let's just say that you wanted to get into Orbiter and you didn't really want to think about, planning or anything. You just want to get in and go to Mars. Is that even possible? Can you go to Mars on any particular day of the year? Well, let's find out. So I'm going to do a couple things here. I'm going to start TransX down here, but I'm also going to start TransX up here to get that nice large view that I like. So let me get that moved over here and make it even larger. And bear in mind, again, remember, we're not going to use this plan to go to Mars. I'm just showing some stuff here about the date. So also let me mention that if you're brand new to TransX, if you've never used it before, then going to Mars probably isn't the best place to start in terms of learning how to use TransX. So I have some other videos where I've gone from the Earth to the Moon, and I've gone from the Moon to the Earth, and those kind of in those videos I do my best to try to do a lot of hand-holding and explain TransX in just a lot of detail. So if you've never used TransX before, I would recommend at least taking a look at those videos first. So in the interest of time, I don't really want to go through as many details as I did in those videos for explaining just all the basics of TransX. If I do that in every single one of my videos, then I'll never get any of these done. Okay, so now that that's out of the way, let's get started. We'll select escape here, because obviously to get to Mars we need to escape Earth and get into orbit around the sun and go out to Mars. So then we'll go forward, and now here this shows the sun in the middle, and this would be the Earth. So we'll select ++. Now we've got Mars. So now we've got the sun in the middle. This is the orbit of Earth around the sun, and this is the orbit of Mars around the sun. This blue line points to where Earth is currently at in its orbit, and this line points to where Mars is currently at in its orbit. So now I'm going to press VW to bring up the eject plan, and I'm just going to go about the normal way of doing what we need to do to get to another orbiting body. As I'm adding prograde velocity, you can see this dashed yellow line extending out. And again, remember, if this is the orbit of the Earth and this is the orbit of Mars, then you can see this dashed yellow line getting closer to the orbit of Mars. So I'm just going to continue adding some prograde velocity until we are touching the orbit of Mars. So now, if we were to leave Earth at this point and come all the way out here, we would touch the orbit of Mars out here at this point. But we have a big problem. These dashed yellow lines here, this long dashed yellow line and this dashed yellow line, represents where we would be versus where Mars would be. And we are way off. According to TransX, we are not even close to Mars at that point. So let's see what it takes to make these dashed yellow lines come closer together. So I'm just going to continue adding prograde velocity. You can see the closest approach is coming down. So I'm continuing to add prograde velocity, and these lines are getting closer and closer. And you may note, if you're observant, that even though these lines are getting closer, which is a good thing, our projected orbit goes out here beyond the orbit of Mars, and then we swing way, way out into space and come back in before we get back over to this point where these two lines are starting to come together. And just consider how far out into space that is. If this is the orbit of Earth, and that's the orbit of Mars, then if we add this distance, or if we compare this distance to this distance, then it says that we're basically going out past Mars as far as the orbit between the Earth and Mars all over again. So that's way out into space. But let's just take a look and see, what it takes to get to Mars using this date. So I'm just continuing to add prograde until I see the closest approach start to go up, which it just did. So now I'm going to back off and get this down to its lowest point. And it looks like get into a finer setting. Looks like about right there is as low as that's going to get. So now if I wanted to work with this date some more, this date here, then I would come over here to the change plane variable, and not really knowing which way to go, I would just add in some plus plus, and that's actually the right way. If I'd added negative, then you can see this is just making everything worse. So what I would do there is just reset it, and then add in some positive plane change, and you can see the closest approach coming down. So just add in a little more, and you can see the closest approach continuing to come down. And once it gets down here below 500 kilometers or thereabout, what you can do, or I should say, 500,000 kilometers, you can go forward on this side and bring up view and counter, and this will give you a much more accurate picture of exactly what's going on. So let's just continue to refine this. Make adjustments as necessary. Okay, so right there around 487 is as low as that's going to get. So I'm going to go back to prograde and work with this a little bit more. And you can see down here, where this green line represents our projected orbit. And of course that in the middle is Mars. So we can see that our minimum altitude at this point is coming down. Let's go to a finer setting. And it looks like we need to go back to the change plane at this point. And we just go back and forth between these variables until we have the lowest point. Okay, it's going up now. So we'll back off and back to prograde. Okay, now back to plane change. Go to a finer setting. Back to prograde. And we're getting in really close now, but we can refine it a little further. Get into a finer setting there. And that's basically got us at Mars. Let's just see how close we can get. Right now I'm just looking at the minimum altitude. Once you get down below a few thousand kilometers, you can ignore this rough closest approach and you just want to focus on the minimum altitude. So let's go back to prograde, and that's got us hitting Mars now. Do one more refinement here. Okay, so that's got us out to Mars, but let's take a look at what's going on here. In order to get to Mars using this scenario, or using this set of calculations, we are not going to get to Mars until this date, 56780, and today's date is 56148. Now let's see what that means. Just doing a little subtraction here. If we take 56780, that's the date that we would get to Mars, minus today's date, which we said is 56148. Then it would take us 632 days to get to Mars. Now clearly that is less than ideal. You know, what is the usual time to get to Mars? It's like 8 or 9 months. So taking close to 2 years is not very good at all. Not to mention the fact, you know, besides all the life support that would require, let's just see how much, you know, prograde velocity we're using to get out to Mars is, you know, 5,395, and our encounter velocity once we get there is 7,354. So by going to Mars on the wrong date, let's just call it the wrong date, yes, we can get there, but we're going to use a tremendous amount of fuel, and there's no benefit to even using all that fuel because it's going to take us, you know, essentially forever and a day to get there. So that's really what I wanted to point out in this first video, is just how critical it is to pick a good day, you know, to pick a good launch day. If you don't care about fuel usage, perhaps you're going to set orbiter up with unlimited fuel, and maybe you don't care about the time because you're just going to use 100,000 time acceleration to get over there anyway, you know, then by all means you can pick these obscure dates and just jump into orbiter and go whenever. But if you want to do things, you know, a little bit more efficient, a little bit more realistic, then you want to pick a good day. So that's going to be the end of this video, and we'll see you in the next part where we'll start talking about good launch dates. Okay, welcome to another Orbiter 2010 video, and this is actually going to be a series of videos where I'm going to try to show how to go from Earth to Mars using TransX. I've already done an Earth to Mars video using TransX, but I wasn't all that happy with the way it worked out, and I felt like it could use a lot more. How important the date is for getting out to Mars. So you can see here, hopefully you can see, it's kind of hard to see these colors sometimes, but up here you can see it says the date is Thursday, August 9th, 2012. It's kind of an arbitrary date, nothing special about it. But, let's just say that you wanted to get into Orbiter and you didn't really want to think about, planning or anything. You just want to get in and go to Mars. Is that even possible? Can you go to Mars on any particular day of the year? Well, let's find out. So I'm going to do a couple things here. I'm going to start TransX down here, but I'm also going to start, let's get started. In this first part, I'm actually going to talk just about the date. So we're not actually going to get going to Mars in this particular video. So I'll just kind of warn you right now. In this video, I'm just strictly going to talk about more detail and a lot more, just a lot more explanation overall. So I'm going to do that video again, but this time I'm going to break it up into as many parts as I feel is necessary in order to get an explanation that is hopefully thorough enough to make me feel content that I at least did my very best. So let's